Memspect. Many people have so many questions. Let's just answer them. First of all, you guys know how you guys watch like YouTube videos and like they ask you to subscribe, but you don't subscribe at the last. So I'm just gonna do it right now. Like you guys can know me. I'm a fresh grad, and I went to UCSC to fine tune LLMs. And I'm also looking for like MS stuff. And like if you guys are like also hiring, like I'm just here. Call me baby, right? So yeah, I'm just just want to like work on like big large scale service stuff, but instead I'm just working on compilers. You know how fate works. So yeah, I just like a lot of stuff, and also this entire like PPT is just themed of like Zig because I love Zig. Right, let's go. This was actually finally a project of mine for my bachelor's degree. Many people assume it's like PhD, MTech, but no, this was just an entire bachelor's thing. This thing was just done with just hopes and dreams and just me. And like they were teammates, but you know how it goes, right? So imagine, I want you guys to have like a normal scenario, right? You guys are like the strategic command, right? You are like with contractors, obviously. You guys, I'm just going to read this off here. You're the head of the strategic command of the US Air Force. You have to meet with the software engineer who's producing the onboard software for your missiles. You being the cracked engineer, obviously you guys are like super talented. You just found the code and found multiple leaks. Can you just like shout like what you're going to do? What's your next plan of action? Your $100 million missiles have memory leaks. I just like want to know what you guys would do. Okay, and I guess you guys are sleepy. So I'm just going to say, I'm going to like spoil it to you. They say yes. Surprise, right? Like the man literally just says, double it and give it to the next person. But in this case, it's missiles. So the lesson here you got to take is memory leaks. People like not care about memory leaks until it just explodes in their face, right? So why did I come up with this scenario? You can see the source is just life experience cause yeah. So one of my professors just like sat me down and say like, Hari, Lamb Research has been losing like $40,000 a year because of memory leaks. What do you want to do? Sir, I came for like final year project, like just web design, like what's this? So like they just like pulled me down this rabbit hole and just got me into this stuff. So I'm just going to go through some like really cool debuggers, right? Which I like find cool. One is from like Epic Games. It's called a RAD debugger. Like you can just see this like this beautiful display of like it's just so beautiful, right? You can just have the debugging flows, you have the visualizers. It's just so snappy. And another one which really inspired me to like really take this project forward is Reed Hastings' Purify project. I don't know how many people are from like the 90s. I mean, like who actually use this for the Linux software, but this was apparently like really good. But yeah, so Reed Hastings, like being so talented, he just dropped this and just went to go Netflix. And the other one is Jane Street. Yeah, the HFT I've been trying to get in since second year, but they just never like look into tier 3 students, I guess. So yeah, Memtrace is like really unique because it's not like an actual memory debugger. They actually base it off so OCaml comes up with its own like memory profile technique. It's just like a tracing tool. So yeah, I just like want to into because just in case like Jane Street watches this. Right. So I just want to go, right. You have these memory leaks. What are the solutions, right? I'm just like put solutions note to man, and this man here is like me. Like this is what I know. If you guys know more, I'd love to like know more about it. So you have your ASAN, you have your Valgrind, you have your SVF, you have your SPCA, you have so many tools. But what are the problems here? So most of them, like people tend to use like dynamic analysis, right? So you have this like heavy, fast ones, which actually like works, right? Like if not for Valgrind, I don't even think we could have like found the XE problem, the entire Xiantang information. I think it was a Microsoft engineer, probably, yeah. So yeah, we have all of these issues, and it's just people do not just take static analysis seriously. And I'm always like I root for the underdog, right? So I came up with my own framework. It just started from a memory leak detection. Now I just created an entire framework for static analysis. So like I'm just going to like define it, right? Memspect, a general purpose tiny static analysis framework. The emphasis is on tiny because I like programs that work like that is fast, right? Usually when you like test something, you don't want to like wait for like hours. Like if you guys do like work on Rust, you'd know how long it takes to like compile things. So yeah, that's why I said like I just want to like tweet quick, easy, efficient, simple, and I want it to be like both academics and industrialists, right? I just like want like let's say you take like a big code base. Let's say you work on the Linux kernel, right? Let's say you work on the XE itself, right? And let's say you want to like do some static analysis, right? Some just some testing. just to make sure nothing happens, right? If it was dynamic analysis, you had to like actually like bring out the .bin file and like actually perform things on it. Like Valgrind works that way. It's basically a virtual machine that does just-in-time compilation and adds instrumentation code. I don't got no time for that. I just like want to know if there's a memory leak, dude, right? So like, I just like want to keep it simple, clean, fast, right? So this is a general architecture. This is just like the default architecture. Can you guys see? Okay, nothing's visual. Never mind. Phase one, recursive module using LLVM. How many people here actually like LLVM? Right. How many people hate the docs? Do you guys like hate the docs? Right. Yeah. Okay. You guys know my pain. I try to for here, I'm just like, just for people who do not know, this is how an LLVM works, right? It just takes a C code, pros JST. You guys know more than me, so I'm just going to skip over it. And yeah, here I use LLVM IR. I accidentally tried to like build like an entire IR, like from the spec sheet, like an IR parser that went really horrible. You guys can try like the while IR or MLIR for this. And like, probably you get, essentially we need an intermediate representation. So it makes it easier for us to like pass through code. And when I say code, I usually mean code bases. All right. When I'm just saying code bases, how should I put it? More than 50,000 lines, probably, right? So any medium scale project, more than like 50 people working on, right? Like anything bigger that your PC start to actually like hesitate, right? So yeah, what the thing I did is to use a Clank's own plugin because I'm not going to like create an entire thing. So and the LLD plugin I used here. So this is really interesting. The reason why I used LLD plugin is because the LLVM Gold plugin is deprecated, and majority of static analyzers such as PCE, SVF, they all just use LLVM Gold plugin, and every time I go through it, it just doesn't work. So LLD is like really fast. You guys have to go like look at the benchmarks. So I just like used LLD, and yeah, can I see the code? Right. So just a normal. I just used the fast invest square root. Do you guys play Doom? Any fans of Doom here? Doom Eternal, Quake. Oh, cool. Right. So yeah, if you guys know Doom, obviously you know the Quake fast invest square root algorithm. I just took it as a example, and the IR looks something similar like this. So the computer obviously cannot like know whatever this is. Like the computer does not understand English, so it's just going to go with IR, right? And IR is like pretty simple. It has like barely any pass cases, right? So essentially, the first thing you're going to do with Memspect is take your entire code base, bring it to an IR. Next, that is alias analysis, right? To put it in simple sense, it's just relationships between pointer variables and memory locations. This is, I think, at least like the fastest way in which you can like track programs, like drag control path, right? And I just went with Steenscard and Anderson's, very popular. If you took like any like advanced compiler design course, I'm pretty sure you'll just run into it, right? And many people have like been fighting with me, just so I've been like put this entire Stack Overflow, right? Point analysis, point two analysis, alias analysis, same thing. Like maybe a little bit difference here and there, but I do not want to die on that hill, right? Right. I'm just going to like do a quick speed run, right? What's the points two pair? Simple. You just take P holds address of X, right? Q holds address of P, right? And what does P hold? P holds address of X. So and X holds the value of 1. So essentially we have like a set where each superseding thing is a memory location of it. So yeah. Right. So challenges to point analysis. Obviously, with compilers are like hard, very slow. You have to like run tons of optimization. So these are like just like a small, like how should I put it? A small like glimpse into what are the problems we ran into, right? But we will go through the optimizations. At least I did. And yeah, this is just the difference between context flow sensitive and flow insensitive. Same thing, context sensitive, context insensitive, right? So essentially, flow sensitive analysis computes a distinct results for each program. Insensitive one, like my dad, like he just like, doesn't give, doesn't care about anything I do. So he just gives like one single result, but every time I do it, I'll just show you something, a bit of example, right? So you can just take it, a good example. As you can see, flow sensitive just gives you one result. So it's actually like cares about you, right? So every time you run, it just like updates over it. But flow insensitive doesn't care. It's just like gonna keep on going and it's just giving it to all in short form, right? And I'm just gonna like give an inference over here, right? So you can see with flow insensitive, these things here are like precise, right? They might be computational heavy, but they're precise. Insensitive, they just want to run. They're like pirates. They're just wild. The same thing goes for like context insensitive. You guys can like almost like make it out, right? What's Anderson analysis? So Anderson analysis is basically flow insensitive algorithm. It has like no notion of control flow. The control flow gets updated each time you run it, like I keep saying. And it's just obviously it's just O of n cube, which is just hell. So you can see with the first iteration with the code, you can see like first it just takes P of A, S of P, R of A, Q of B, and S holds of Q. But in the second iteration, as you can see here, the B's actually added. How? So when you go it again, so you have like P of A, S of P, but we already know that S has Q. So the Q is added there. And we know R holds S holds Q. So it's basically like Mitch packing, like it's just matter. What? Wait, why am I having a stroke? Pattern matching. My bad. Right. So let's go to Steenscard. Steenscard takes a nice approach. This is computationally a little bit heavy, but it's like precise because they just unifies it in one go, which is like really interesting, by the way. Like I have no idea how they did it, but this paper is like really cool. Just did in almost linear time. Just imagine it from O n cube to just like O of n alpha n. And as you can see here, like you can just, I'm just going to like give you some time to like go through the code, right? It's super simple, right? So A holds B, B holds C, A holds D, so BD. Let's go. So I'm pretty sure you guys do not understand because I'm going super fast, but I don't think I even have time anyway. So yeah, I hope you guys still at least like got the mere context of it. It's simple. You guys will get it. Right. So next step. So what we are doing here is we got the IR and we have a method to actually track the pointer locations, right? But in this case, I want to like just like put it out there like a disclaimer that Memspect is like entirely configurable. If you guys want it, you can just like take pointer analysis out and like substitute with anything else. You want symbolic execution, just implement it. It's like that cool. Essentially, the way I've done this is because these three categories, alias analysis, interposition construction, and like actually like detecting memory leak is like most common. Like I just like want to have like a default option, right? So I just like have it here, but you guys can just like take one thing out, take one, put another. So yeah. Right, interpositional data dependence. So for now, as you've been seeing, it's all just a single file code, right? It's just a single code, you guys do it here. But when you think of it something like having a library, right? C code bases are like barely simple. You have like complex pointer operations going on here and there. So what do I want to do, right? So how do we all just put this together? So this is where the actual optimization starts. So first thing first, we're going to have an actual data dependence, right? We're going to have an interprocedural data dependence, as the name suggests, like in between procedural, like when you go through functions, right? And we're going to also add the like parameters too, right? So we got to like track the data. And so here we are going to use this classic algorithm, iterative data flow analysis. If you guys have read the Dragon book, you guys could actually find it here. That's where I got at least the inspiration from. And also there's like no implementation of it in the internet whatsoever for some reason. But yeah, so but this thing I really like it because it's not only used for like memory leak, but you can also use taint analysis and impact analysis. Just to like give you a short meaning of like what these are. Taint analysis is just like finding security vulnerabilities of your code, and impact analysis like what happens if what happens if a pointer just disappears, like a null pointer happened with CrowdStrike. That's why I just like even mentioned them. Maybe they shouldn't use Memspect, you know. So yeah, what's the thing here? Like, what do we do to like optimize this when it comes to like large code bases? I'm going to do something called partial call path analysis. Essentially, what it is, the developer gets to like limit the functions. And as you can see here, like there's like two functions, FA and FB, and I can just say just stop with FB, just do it. I just don't want to go like 7 function deeper and have a breakdown. So like that's all of it, right? So now we have all of this, like we've done so much. So how do we actually like compute the memory leak? This is the easy part. This is the most beautiful part in my opinion. Essentially, we just check the reachability of the data flow. Like does the pointer actually like, is there like a data path to the free algorithm, right? Is there, I mean, I'm sorry, the algorithm is the code, right? Is there a free code? Does it have something? If there is like no path, it's a memory leak. The memory keeps allocating and it does happen nothing. But here's also another like interesting side effect, which even I did not realize. If the control path could go into the leak path and the data flow couldn't, it's a partial memory leak. And it is also like something that it comes along with partial call path analysis, right? So yeah, oh, oops, never mind. Okay, yeah. So yeah, what are the applications I want for Memspect? What's like the dream for Memspect, right? So obviously with like cache use, especially embedded systems, not looking at you Boeing, right? They have, yeah, it's over. So it's just like some minor benchmarks with the gzip code base, and yeah, like we got like pretty like accurate stuff, but not really much. Again, it's just a solo day. We have like so much experience to do, and that's about it, right? This is just like the scope. I accidentally chose Go and I regretted it, right? Don't use Go for like a systems language, better off for the web. So I'll be trying with Rust and Zig. I'll be benchmarking with this famous benchmark code base such as Spec CPU 2000. It's like $2,000. I don't have money, so like I'll probably find something else. But yeah, I will be adding new features like flame graphs, visualizers, debugging flow, just like RAD. I mean, like, probably not like RAD. Sorry. Yeah, I mean that's about it. Sorry for speed running. If you guys you don't understand anything, I'm always free. You guys can hit me up. Thank you so much for your time.
All right, we have time for maybe a question or two. In the meanwhile, I request the next speaker to set it up. Questions? All right. Questions? Okay, the switch case goes to default.
So, what is the false positive rate in your analysis? I mean, how many false positives did you find?
Right. For the false positives, it's more like I had false negatives more than false positives, interestingly. Because like with static analysis, the thing is that you look at all executable paths, right? And like unlike dynamic analysis. So with the false positives, I would say it's pretty much lower in case of like SVF and PCA. I'm sorry, it's not possible. Okay, like, do you have like any reasoning towards it? I mean, again, I just tested like very badly, so.
No, no. If you're using Steen's analysis, I just can't believe that false positive rate is very low.
What answer? Sorry, I can.
Steen's analysis using
Steens.
Steen's.
Oh no. Okay. My bad. I forgot to mention it. Developers can choose between Steenscard and Anderson.
No, no, I'm saying with that analysis, what is your false positive rate?
We never really actually another thing.
I think you should go and study it.
Yeah, we should like this is like more testing to it.
Let me put it very politely. There's the worst points to analysis
it's
that
true.
one can use.
I'm just like again, it's just I just want to like save time for the developers, like, and it's just of linear time. So like you really can't like make a difference. But yeah, I want to like empower developers with like various algorithms, not just Steenscard or anything. It has to be like very developer friendly. Yeah.
Right. Thank you. Let's thank the speaker once more.